with the knowledge of these reflections, now let us proceed to image formation. Here we have one formula. It is a formula of spherical mirror, which is applicable for both concave and convex mirror. It gives the relationship between this equation, gives the relationship between these three quantities. These are distances these are the distances measured from the pole. F is the distance between the focal point and the pole. U is the distance of object from the pole. V is the distance of object from the pole. All these distances are measured along the principal axis. And we have one more equation. It is formula for magnification. Formula for magnification. It indicates enlargement or reduction of image. It happens in spherical mirror. The mirror image size, either it gets enlarged or reduced after reflection. So this indicates the enlargement or reduction of the image. So it is in 4 different equations. All of them have the same approach, magnification. It is the function of height. That is ratio of two heights, the height of image divided by the height of object. Is ratio of the two heights. And the second equation is a function of V and U. And one more equation is a function of F and U. Another equation is a function of F and V. We get these equations from this equation with this as a function. And these quantities are assigned with sign conventions. They will take the sign conventions. Sign convention means the quantities are either positive or negative. And these distances, what we measure from the pole, if you measure the distances in the direction of the incident ray, these distances, if you measure in the direction of the incident ray, they will take positive values, and they will take negative values if you measure them in the opposite direction, negative values in the opposite direction. And also these quantities also take the sign convention positive and negative. The H takes positive if it is upright, it is vertical, upright, either this or this, and it takes negative if it is inverted, either image or object. And M also, after the calculation, it is either positive or negative. If the M value is negative, it is the image, what the image you get is real and inverted. Image what you get is real and inverted. If M value is positive, it is virtual and erected. That is the difference. That is the sign indicates. The value indicates whether it is enlargement or reduction. If it is more than 1, the image is enlarged. If the image is less than 1, that is magnification is less than 1, the image is either reduced or diminished. Case of this. Now let us look into the relative positions of the object and the image in case of concave mirror. All these cases are concave mirror. Let us understand what is the relative positions of object and image. So they are interrelated. Any variation of one, it varies the other. That is the relative positions. In the first case, let me take the object at infinite distance. The object, as you know, has its own shape and size. I am taking this shape as object, arrow mark as object. Now it is at infinite distance from the concave mirror. Infinite distance. When the light falls on the object, the light reflected from the object, and those rays moving towards mirror, and those rays which are near this mirror, but they are coming from the infinite distance. It is an infinite distance. Those incident, they are called as incident rays. When they are approaching mirror, almost all of them lie parallel to the principal axis. Only in case of when the object is at infinite distance. All the incident rays taking at every point on the object, you see that countless number of rays are reflecting. I am taking one ray at the tip of the object. This is at the tip of the object. One ray parallel, that is one ray. And at the bottom point, at the bottom of the object, I am taking one ray. There are many rays. Every point is a countless number of rays are reflecting. Taking this point and this point. This ray is parallel to principal axis. This ray is parallel to principal axis. After reflection, as you know from the previous knowledge, they should pass through the point F. That is the point of focal point. That is F. Reflection and reflection of incident of this reflection and reflection of this incident ray passing through this. And they meet at this point. It means that the image is forming at this point. Here, this point, here interception at this point is also appear at this point, and this point also appear at the same point. There are two distinct points which differ the height of the object. But both of them converge. This point and this part, both of them converge at this point. So image is completely diminished to 0. Magnification is 0. This point as well as this point observable as image at this point only. Imagine that. Completely it is diminished into a point or negligible size, which you cannot see almost like that. But image is forming as a point of the point image of this, whichever the size, whichever the bigger size we have. So that is the image is real image because after converging at the point in front of it is real image, but magnification is 0 since here height of the image divided by height of the object. This height of the image is 0. This height as this 0 by everything is 0. Magnification is 0. And the distance of object from this point here infinity minus infinity, because we are measuring in the direction opposite to the incident ray. And distance of image, it is at P equals F, it is minus F in the opposite direction, measuring from here to here in the opposite direction. So V is equal to minus F, U equals minus infinity, M equals 0, real image, invisible image of course. This is a kind of image formation when the object is at infinite distance with respect to concave mirror. And the second case, I am taking the object at the point somewhere beyond, just beyond C, not at infinite distance. And the object is on the principal axis. It is not on the principal axis, of course. The object is on the principal axis. It is beyond C. Let us understand where we get the image in front of this concave mirror. You have to take this, the point on the tip of the object and point at the bottom of the object. Since the bottom is in touch with the principal axis and the image what is forming is also in touch with the principal axis, but you don't know where it is. Since the incident ray is along the same ray and reflected ray is along the same line, since it is a normal to the mirror at this point. This point, the point at the bottom of the object and the point at the bottom of image what is forming always in touch with the principal axis. That is one thing is clear. Now we have to find out the point at the tip of the object. Where you get that image, that point, image of that point. For that you have to apply this technique. Let me take the point at the tip of the object. There are countless number of rays at this point only in all directions. I am taking the ray like this. In the diagram, it is parallel to the principal axis. The ray parallel to the principal axis. I am taking one ray. Let us not take all the rays to get confused. And one more ray from the same point. Let it be along the point 3, along the point C. Incident ray and reflected ray again back. So any ray along the point C, it is always normal to the mirror at this point. So incident ray and reflected ray lie in the same line. I am taking these 2 points. At least 2 rays we need to take from this point to understand where we get the image of the point. So now let us see that after reflection from this you should pass through F because parallel to principal axis. After reflection it is passed through the same line. Incident ray, reflected ray. That is a reflected ray of this ray, a reflected ray of this ray. Both of them, what is that? Intercept at this point. So if they intercept at this point, this must be the point on the tip of the image. This point is visible here. And all the rays which are coming from this point and after reflection, coming only from this point only. After reflection, they pass through only this point. Intercept. This point of interception is the point of image. So this is the point of image, tip of the image. and remaining, what is that? It should be vertical to principal axis. It also should be vertical to principal axis, in touch with principal axis, in touch with principal axis. So you can draw the diagram. So correspondingly, there is image formation after reflection like this. This is the position of the image for this object. At you, size is less than this, and it lies between C and F. Right? This what is U? Distance of object is beyond C. Distance of image between C and F, and the value of M greater than 1. It is less than 1. Sorry, value of M less than 1. It is reduced, diminished. And when you find the M value is minus, because M takes minus value, it is inverted, it is erected. Minus for this, plus this. Minus divided plus minus you get minus value. You will get minus. The image is known as real image, inverted image. It is a real image, inverted. A real image always you get by converging the incident rays at the point. This is the second case. And the third case, let us take the position of the object. From here to, let us take it on the point at C. I am taking the object at point C perpendicular to the principal axis, on the principal axis. Find the position of the image. Apply the same technique. I will take only a point on the tip of the object. From there, I will consider any two rays. This is one parallel to principal axis, and one more ray that is passing through the point here. You take any two rays, either this or this, like this. So this is possible. So these two are incident rays. As you know, after reflection it will pass through F, and after reflection it passes parallel to the principal axis. That is extended. There is a reflected ray where they meet at this point. This is the point, is the image of the point, this point, tip of the point. So tip of the image is this, and it should be vertical, touch with this principal axis. So this is the image. Draw the image like this. So that what kind of image we get? First of all, what is U? U is minus this, minus C. V is minus C. Minus C, because minus the distance of object from the point. Distance of the image from the point, same point. And they are minus because they are measuring in the opposite direction. Minus C at the same distance. When you find the magnification exactly equals, shows that the size of the image same as that of size of object. And gives negative value, M gives negative value, shows that the image is real and inverted. This image is real and inverted. Minus indicates. And the next case is this case. Let us change the position of the object from C to between C and F. Let me take the object between C and F. Find out the image formation. Apply the same technique. Take the point on the tip of the object and two rays like this. One is parallel to this, and also you can take this for passing through principal axis. The ray, because in all direction rays are reflection take place. Let us take as per the knowledge will take this. Can we take this? You can take this. After reflection, as it is passing through F, and after passing through reflection, it is parallel to the principal axis. Let us extend this reflected rays, both the rays meet at this point. Behind C. This is a point of the image, position of the image perpendicular to the axis. This point and this point is in touch with the principal axis. So look at this image is larger than the object at this position. U is between C and F, V is behind C, that is behind C we get. This is what just inversion of this. And when you find the value of M greater than 1, image is magnified, size of image is greater than the size of the object. And M equals minus indicates it is a real and inverted. Real image and inverted image. This is the fourth case. And one more case. Fifth one, let us change the position from this point to the point on F, focal point. Let us pick the object at this point and find the image position. Let us apply the same technique. A point on the tip of the object. Take the ray like this, parallel to principal axis. After reflection passing through F. Ray parallel to principal axis after reflection passing through F. That is what the usual notation. I am taking one more incident ray. It is in the direction of, that is C. It is C. If we take the ray like this in this direction, it is always along this line. It is normal to the mirror at this point. So incident ray reflected along the same ray. So this incident ray lies along the line normal to the point of the mirror. So after reflection, it is again the same line. This is a reflected ray. And if you take this ray like this, I am taking two rays. And this ray, look at that, extend, they always remain, they are parallel to each other. They never meet. It means they meet at the infinity. We get the image at the infinite distance. But we cannot see the image infinite distance. So when the object is at F, image position is at infinite distance that we cannot see. There is a difference. U equals minus F. V equals minus infinity. At infinity, the image formation. Minus in the opposite direction. M is minus, that is real inverted, that we cannot see at infinite distance. These are the 5 types of image formation in the concave mirror. There is one more, that is sixth case. If the object lies between F and P, the image formation, let us understand that in the next session, and also image formation by the convex mirror, in the next session. So with this diagram, it is clear. Object at the infinite distance, as it moves towards the concave mirror, what happens? The image, what is that? Image moves away from the mirror. As the object moves closer, image moves away and the size increases. Size of the image increases as the object closer and closer to the concave mirror. So the size increases from points here, point size to this size and this size and this size. Image becomes more and more, that is the enlargement. It increases in size as the object moves closer to the concave mirror. So that is what we understood. With this, let us wind up this session. We shall continue in the next session. Thank you very much.